Well, here's where we really run into our first problem. We have not explored this particular case for exponentials. What if we had something like 3 to the 1 over 2? Up to this point, we've had nothing but whole numbers, integers. So, 3 to the 1 over 2. I wonder what question that asks. This would be asking the question, what thing times itself this many times? That's very strange. What thing times itself a half a time? Well, I don't really know what that exactly means. So let me rethink this. How would I get rid of the 1/2? I guess I could raise all of this to the 2. And then I could use my radical rules. So if I treat both sides of the equation fairly, which is to square both sides, then that would say 3 is what x squared is. So really what I'm asking for is, the thing that's squared gives me 3. Now we have another way to write this. When we want to undo what's on x, which is the square, we'll often do a square root. So this is saying that the square root of 3 is what x is. And most of you are quite used to this, and you're quite used to seeing this little rule here. So when we start from 3 to the 1/2 is x, we can see why that runs us into seeing that it's really asking for the square root of x. Now likewise, if I had something like, say x to the 3/5, we might ask ourselves, what does that mean? Well, if that's some unknown letter a, and you notice I'm fiddling around with lots of letters here. This is algebra, right? So you can be chucking lots of letters at you, and you just have to be comfortable that x in this case means something very different from what x meant there. That's why the big bar in the middle. Now, x to the 3/5, again, we could raise both sides to the 5th. So if I did that, I would eliminate the denominator there because I'd multiply on. So let's do that. I have x to the 3/5, and we raise this all to the 5, and then being fair, I raise the other side also to the 5. And some of you may be going, hey, what if things are negative? And we'll come to that. So for the moment, everything's just positive and nice. What if we have then? So that 5 cancels there, and we have x cubed is equal to a to the 5. So it looks like I'm asking for the 5th root now. So if I was to take the 5th root, so how do we write the 5th root? Most of you are used to this. So this would be x cubed. I'm asking for the 5th root, so we put the index right there. Now we're going to have to take a look at this general form and make sure we're all pretty happy with it. So let's do that. So here is our basic radical symbol, and some people like to put a little tiny hook here just so that you keep all of the things that belong inside the radical symbol there. Now this space in here, this big area here, is called the radicand, and it is the thing that we're going to be taking the square root of, or the cube root of, or whatever that might be. And then right over here we have a thing called the index. So whatever ends up in this little space here is called the index, and this tells us the number of things we wish to have multiplied together to get the radicand. And this fancy symbol is called the radical symbol. So this is all together the package. Now let's just review that a little bit. So let me pop this in here. Let's practice with, say, 2. Let's have a 7th root of 2. So this is saying, what thing times itself 7 times gives me 2? And so I can rewrite this in exponential form, and this is what I want you to get used to doing, going back and forth as you might need to. So that is really the same as 2 to the 1/7. Because I'm really asking for the thing that times itself 7 times will give me 2. So another way to say that is that 2 is equal to something to the 7th. So all of this is what a is. And that's the thing I'm after, whatever this thing is equal to. So if I raise whatever this thing is to the 7th, I should get 2 out. Now one might guess whether that's larger or smaller than 2. And if I'm going to raise something to the 7th, which means I'm really going to multiply it times itself 7 times. So I'm going to have a lot of a's here, and my computer has decided to go a little wonky on me here. So I'll have to kind of see if it comes along pretty quickly. Here's another a. And I'm going to have to multiply something times itself 7 times. So if I'm doing that, it should be pretty small, like close to 1, 1.5, or 1.1 or 1.2. Because if I took a number like 2.3, that's going to be bigger than 2. If I take something less than 1, it gets even smaller, so it ought to lie somewhere between 1 and 2, and likely closer to 1. Alright, so that's an introduction to the radical symbol. And the previous page, let's just remind ourselves there, we have some of the rules of how we get back and forth between exponential form and radical form, and we also have then all the rules at this point for how to deal with negatives, how to deal with whole numbers for exponentials. And then next up comes all the rules for radicals, and you'll find that they're quite similar in a lot of regards, and that when you're not sure what to do with a radical, that you can usually just turn it into an exponential form and fiddle with it there, and then return it to the original radical form if that's what's required by the problem. So let's get down to that.